Welcome back to the deep dive. Today we need to talk about a feeling that I think every single person listening right now has experienced at some point. It's this very specific kind of frustration. You're standing in the grocery store, you're looking at a carton of eggs or pound of ground beef, and you have this sinking realization that the price on that sticker, it just doesn't make any sense compared to what you remember.
The sticker shock moment, it hits you right in the gut.
Right, but it's more than that. It's this dissonance. You go home, you turn on the news, or you scroll through your feed and you see a headline. Inflation is down, or the economy is strong, purchasing power is stable.
And you just don't feel it.
You don't. You look at your bank account, maybe you even got a decent raise this year, but somehow you feel poorer. You feel like you are running faster and faster just to stay in the same place.
It's a phenomenon that some people have started calling macroeconomic gaslighting. The official data says you're fine, but your lived reality, your actual experience says you're bleeding out, financially speaking.
Exactly.
Yeah.
And usually when we talk about this, we just complain. We complain about corporate greed or, supply chains or whatever the topic of the day is, and then we move on. We treat it like the weather, something that just happens to us.
Right. Something we just have to endure.
But today, we're doing something different. We are digging into a source that claims the problem isn't just prices going up. The problem is the ruler. The very ruler we are using to measure the prices in the first place is broken.
We are looking at a fascinating, and I'll be honest, a fairly dense article by William L. Weaver. It's titled The Gauge Theory of Value.
The Gauge Theory of Value. Okay, even the title sounds like it belongs in a physics lab, not an economics class.
And that's because it does. I mean, that's the whole point. Weaver is arguing that economics has been stuck using 19th century math while physics moved on to general relativity and quantum mechanics 100 years ago.
So he's basically saying economics is still riding a horse and buggy while physics is flying spaceships.
That's a great way to put it. And he's proposing that we fix this broken ruler of money by applying something called gauge theory, which is, a cornerstone of modern physics.
Okay, which sounds intimidating, and we're going to get into the weeds of what that actually means. But before we get to the solution, we have to really, really understand the problem. And Weaver starts with this incredible thought experiment that I want to walk through because it really broke my brain a little bit.
The house construction analogy, it's a powerful one.
It is. Okay, listeners, I want you to picture this.
Yeah.
You decide to build a house. You've got your dream plot of land. You hire a contractor. You buy the lumber, the bricks, the glass. You have a set of blueprints that are perfect. Every single dimension is specified down to the millimeter.
Sounds like a standard project so far. Everything's in order.
Right.
Yeah.
But there is a catch, a huge one. The tape measure, the physical tool you and your entire crew are using to measure every single cut, is made of a weird, unstable rubber material.
Unstable how? Like it's just flimsy.
No, it's sensitive to the environment. So in the morning, let's say it's a chilly 40 degrees outside. The rubber tape measure shrinks up in the cold. So the distance between the 1-inch mark and the 2-inch mark gets smaller.
Okay, so if I measure a 10-foot board in the morning when it's cold, I'm actually cutting a piece of wood that is, shorter than 10 real feet.
Exactly. But then, by noon, the sun comes out. It's 90 degrees, the tape measure heats up, and it expands. Now the inches are all stretched out. You measure another 10 feet for a wall stud, and you cut a piece of wood that is significantly longer than the one you cut in the morning.
And you're trying to nail these boards together, the short ones and the long ones.
You're trying to frame a house. The studs are different lengths. The window frames you build don't match the glass panes you ordered. The roof trusses are warped because one side is longer than the other. Nothing fits.
The house collapses. It's structurally impossible to build. It's doomed from the start.
And here is the kicker. Imagine the foreman comes up to you while the whole thing is falling down around you and says, I just don't understand. We followed the blueprints. We measured everything twice.
But the unit of measurement itself was fluctuating. The ruler was the problem. And this is the core of Weaver's argument. In the physical world, what he calls level 1 in his paper, we have constants. We have the speed of light, $3.
A number we all learned in school.
It's 299,792,458 meters per second. It doesn't matter if it's Tuesday. It doesn't matter if you're happy or sad. It doesn't matter who the president is. The speed of light is the speed of light. It is a rigid ruler. You can build a spaceship with it.
But in economics?
In economics, what he calls level 4, the dollar, is that rubber tape measure. It expands and contracts based on monetary policy, based on supply and demand, based on something as vague as consumer confidence.
So when I say that cost me $50, that statement doesn't actually mean anything concrete over time. It's not a fixed point.
It means something different today than it meant yesterday, and it will mean something different again tomorrow. We call this variability inflation, but Weaver suggests that word is actually too soft. He argues we need to view this through the lens of information theory.
Okay, let's unpack that, because he uses a phrase that I absolutely love and also find completely terrifying. Information entropy.
Yes. Think about what money actually is. I mean, we like to think of it as gold coins in a vault somewhere, but in the modern world, money is a signaling system. It's information.
It's not the paper, it's the message on the paper.
Precisely. It transmits value from one person to another. It tells you how much your labor is worth. It tells you how scarce a resource is. It's a medium for information.
It's a radio signal.
Perfectly put. It is a signal. Now, in information theory, what is the enemy of a clear signal?
Static. Noise.
Exactly. Entropy. When inflation is low and stable, the entropy in the system is low. The signal is crystal clear. If you have a $100 bill in your pocket, you know exactly what that represents in terms of goods and services. You can plan your life, you can build the house because the tape measure is steady.
But when inflation kicks in,
The entropy rises. The signal gets noisy. It gets full of static. You have that same $100 bill, but the information it carries is degrading. You don't know if it buys a week of groceries or 3 days of groceries. The signal fidelity of the currency is lost.
that's the anxiety we all feel. It's not just that things are expensive. It's that we can't read the signal anymore. We don't know what expensive even means because the baseline is constantly moving under our feet.
Precisely. And the mission of Weaver's article, and our deep dive today, is to explain why our current methods for measuring this noise are fundamentally broken, and how we can essentially build a noise-canceling headphone for the economy using this gauge theory.
I like that. A noise-canceling headphone for my bank account. Okay, so let's get into the broken ruler. Weaver brings up something called the index number problem. Apparently, economists have been fighting about this since before my grandparents were born.
Oh, at least a century. It is the Hatfields and McCoys of economic theory. It's a foundational disagreement. And it essentially boils down to a cage match between two different ways of calculating the cost of living.
Okay, let's introduce the fighters. Who are we dealing with here?
All right. In the red corner, representing the past, we have the Laspeyres Index.
Laspeyres.
Yeah.
Sounds fancy.
It is the looking backward view. And here's how it works. Imagine it's 1990, you go to the store and you buy a basket of goods. A loaf of bread, a gallon of milk, a movie ticket, and, let's say, a Sony Discman.
Oh man, the Discman. I remember saving up for one of those. And the anti-skip protection that never ever actually worked.
Never worked.
Right.
So that's your 1990 basket. The Laspeyres method takes that exact basket, Discman and all, and it transports it through time to today, 2026.
Yeah.
And it asks the question, how much would it cost to buy this exact 1990 basket right now?
Well, but nobody buys Discmans anymore. You can't even find them at a regular store. You'd have to go on eBay or something.
Exactly. And that is the fundamental flaw. It assumes your preferences are frozen in time. It assumes technology hasn't changed. It's trying to price a ghost. It ignores innovation and substitution.
Okay, so that seems obviously flawed. I mean, it's a fun thought experiment, but not very useful.
Yeah.
Who is in the other corner?
In the blue corner, representing the future, we have the POSH index.
Posh. Okay.
This is the looking forward view. It does the opposite. It looks at what you are buying today in 2026. You're buying avocado toast, a Spotify subscription, maybe an VR headset, and a modern laptop.
A very different basket of goods.
Completely different.
Yeah.
The POSH index takes this 2026 basket and transports it back to 1990. It asks, how much would this basket have cost back then?
But Spotify didn't exist in 1990. VR headsets were pure science fiction. A laptop with today's processing power would have cost, what, $10 million? It would have been a government supercomputer.
Exactly, couldn't buy it. So both of these fighters are throwing punches, but they're both missing the target completely. The Laspeyres Index tends to overestimate inflation because it ignores that we switched to better, cheaper things.
We don't buy the Discman. We stream music for $10 a month.
Right. And the POSH Index tends to underestimate inflation because it ignores that our quality of life expectations have skyrocketed. It's comparing apples to spaceships.
So we have two rulers. One is looking back at a ghost. The other is looking forward at science fiction. Do they ever agree? I mean, do they ever give the same number?
Almost never. I mean, if the economy was perfectly stable, if technology never changed, and we all bought the exact same stuff forever, year after year, they would match. But in the real world, they always diverge. One might tell you inflation is 3%, the other says it's 2.2%.
And that gap,
Yeah.
that difference, that's the index number problem.
That is the problem. And for 100 years, economists have just kind of shrugged their shoulders and said, well, let's just take an average and call it a day. They try to split the difference, maybe use a formula that's a blend of the two.
But Weaver says this is fundamentally wrong. He says the reason they don't agree isn't because the data is bad, but because the geometry is wrong. This is where I need you to explain this flat Earth math idea to me.
Okay, this is the crux of it. Think about a map of the world, a standard Mercator projection, the one hanging in every classroom. Look at Greenland on that map.
It looks massive. It looks like it's the same size as Africa.
Right, but in reality, Africa is 14 times larger than Greenland. So why does the map lie to us?
Because the Earth is a sphere, and the map is a flat piece of paper. You can't flatten a sphere without distorting it somewhere.
Exactly. You are trying to represent a curved surface on a flat plane. The distortion is inevitable. Weaver, and he's drawing heavily on the work of Pia Malaney and Eric Weinstein here, argues that standard economics uses ordinary derivatives. Basically, the calculus you learn in high school, which fundamentally assumes the space of the economy is flat.
Like a piece of paper. But the economy isn't flat.
No, the economy is curved. It is curved by innovation. It is curved by our changing preferences. It is curved by the fact that a Discman is not a Spotify subscription. They exist in different technological spaces. You cannot draw a straight line between the 1990 economy and the 2026 economy because the underlying terrain, the very nature of what we value and what is possible, has shifted.
So when the Bureau of Labor Statistics puts out the CPI number every month, they're basically handing us a Mercator projection of the economy and telling us Greenland is huge.
That is a perfect analogy. They are using a straight ruler on a curved surface, and that is why the measurements always feel wrong. That is why the house collapses. They are ignoring the geometry of the problem.
So, enter gauge theory. Weaver says we need a connection. What is a connection in this context? And please treat me like I failed calculus. Because I did.
Fair enough. Let's avoid the equations. In physics, specifically in a field called differential geometry, if you want to compare two things that are in different places on a curved surface, you can't just slide one over to the other. You need a way to translate it while accounting for the curve. That translator is called a connection or sometimes a gauge field.
Give me a visual. I need a picture in my head.
Okay. Imagine you are standing at the North Pole on a perfect sphere. You have an arrow, and you point it towards, say, New York City. Now you start walking in a straight line, always keeping the arrow pointed straight ahead relative to your path.
Okay, I'm walking, holding my area.
You walk a quarter of the way around the globe, you're now on the equator. But because you were walking on a curved surface, your arrow is no longer pointing at New York. It's now pointing straight down the equator. The curve of the Earth twisted your perspective without you even realizing it.
So my straight line wasn't really straight from a global perspective.
Exactly. A connection is a mathematical rule that tells you exactly how much you need to twist your arrow at every step of your journey so that it stays pointing true north, or in this case, at New York City. It compensates for the curvature of the path.
So we need a mathematical rule that compensates for the economic curvature between the 1990 Discman and the 2026 Spotify account.
Yeah.
We need to know how to adjust our ruler as we travel through time.
Yes. Malaney and Weinstein developed what they call an economic derivative, a covariant derivative that does exactly this. It's a tool that lets you compare value across a curved economic space. And the magic of it is that it separates the signal, the true change in your purchasing power, from the noise.
And noise here means?
It's the substitution effects, the technology changes, the curvature itself.
Substitution effects. That's the thing where if steak gets super expensive, I buy chicken instead, and the government says, look, your food bill is the same, no inflation here.
That's the one. The government says, you spent $100 on meat last week, and you spent $100 on meat this week. Zero inflation. But they conveniently ignore the fact that last week you ate ribeye and this week you ate Spam.
I hate that. It feels so disingenuous. It feels like a lie.
It feels like a lie because it ignores the massive drop in quality. It ignores the drop in your utility, your satisfaction. The flat earth math just sees the dollar amount, the $100, and assumes equality. The gauge theory math sees the curvature. It sees that you were forced to substitute down to a less desirable good. It recognizes that even though you spent the same amount of money, your standard of living actually dropped.
That is validation right there. It's math that actually sees my pain.
It is. And the result of using this correct gauge, this connection, is something called the Divisia Index. Weaver argues this is the geometrically perfect measure of value. It's the ruler that bends with the curve instead of breaking.
So the solution exists. The math is there. But before we get to how we might build a machine to use this math, we need to talk about why the broken ruler messes with it so much on a personal psychological level.
Yeah.
And this is where Weaver gets into thermodynamics.
This is one of the strongest and I think most intuitive parts of the paper. He takes that information entropy idea and applies it to the most famous or maybe infamous equation in monetary policy, MV equals PQ.
The equation of exchange. I vaguely recall this from Econ 101, usually written on a chalkboard by a professor who would much rather be doing anything else.
Yes. It's often treated as this very dry, abstract thing. Let's make it interesting. So M is money supply. V is the velocity of money, how fast it moves around. P is the price level. And Q is the quantity of real stuff being produced.
MV equals PQ.
Right. Now, usually economists treat these as just abstract variables in a spreadsheet. Weaver says, no, let's treat them as physical properties of a gas inside an engine.
A gas, like steam in a steam engine.
Exactly. Imagine the entire economy as a steam engine. M, the money supply, is the total amount of energy in the system. It's the coal you shovel into the furnace.
More money, more coal. Makes sense.
Now, V, velocity, is the temperature.
Wait, velocity is temperature. Break that down for me.
Think about the molecules in a gas. When you heat them up, what do?
They start moving faster, they get agitated, bounce off the walls more.
Right. High temperature equals high molecular speed. Now think about money in an economy. When people are worried that their money is losing value, when there's high inflation, what do they do with it?
They spend it immediately. As soon as you get your paycheck, you go buy groceries or gas or whatever you need now because you know the price will be higher next week.
Exactly. The money moves faster from hand to hand. The velocity spikes. The economy runs hot.
That old phrase, money burning a hole in your pocket.
Yeah.
It's literal in this thermodynamic model. High inflation makes the money feel hot to the touch. You want to get rid of it as fast as possible.
Okay, that clicks. So M is energy, V is temperature. What are P and Q? P, the price level, is the noise. It's the rattling of the engine, the hiss of escaping steam. It's the chaotic, useless byproduct. And Q, the quantity of goods, is the only good thing in this equation. Q is the work. It's the pistons moving. It's the actual stuff we produce, cars, corn, haircuts, software. It's the useful output of the engine.
So walk me through the inflation is entropy scenario using this engine. The government turns on the printing press.
Okay, so the Federal Reserve decides to print, let's say, $1 trillion. They shovel a massive amount of energy into the furnace of the engine. Now, best case scenario, the engine is efficient. It's well-oiled. That new energy turns directly into productive work. Q. We build new factories, we invent new technologies, we hire more people. The economy grows.
That's the dream. That's what they tell us will happen.
That's the dream. But what if the engine is already running at max capacity? What if our factories are already at full tilt and we have supply chain problems? What if we can't make any more stuff? Q is stuck. It can't increase.
So you're dumping all this fuel in, but the pistons can't move any faster.
Right. And according to the second law of thermodynamics, energy cannot be created or destroyed. It has to go somewhere. If it doesn't become useful work,
It has to become something else.
it dissipates as heat and noise. The temperature skyrockets, people panic spend, the money burns holes in their pockets, and the noise skyrockets, prices soar across the board. The system becomes chaotic and inefficient. The signal of the money degrades into pure static.
That is a terrifyingly clear visualization. It's not just greedy corporations raising prices for fun. It's physics.
Yeah.
You dumped a ton of energy into a closed system and you cooked it from the inside out.
Precisely. And this leads us to the part of the article that I think is the most radical and maybe the most important for our daily lives. Because if inflation is just heat and noise, then it doesn't hit everyone the same way. The heat isn't evenly distributed. This is where Weaver introduces the concept of path dependence.
Here's where it gets really interesting. He actually wrote that. Okay, path dependence. This sounds philosophical.
It is. It is a direct challenge to the idea that there is one single inflation rate for the entire country. Standard economics, for the most part, treats your financial life like a state function.
You're going to have to define state function for me.
Okay, think about climbing a mountain. You start the parking lot at the base, that's state A. You hike all day and you get to the summit, that's state B. The difference in altitude between the parking lot and the summit is, let's say, 3,000 feet.
Got it.
Does it matter for that final altitude number if you took the steep, direct, rocky trail or the long, winding, gentle switchbacks?
For the altitude, no. You're still 3,000 feet higher than where you started.
Right. Altitude is a state function. All that matters is the start point and the end point. The path you took to get there is irrelevant to the final state. Standard economics assumes cost of living is like altitude. If you start the year with $50,000 in the bank and end with $50,000, your financial altitude is the same, regardless of what happened in between.
But Weaver says that's not how life works.
Weaver says life is a path function. In physics, things like work and heat are path functions. If you take that long, winding trail up the mountain, you burn way more calories and do a lot more work than if you took the steep, direct path. The path defines the cost.
This makes so much intuitive sense. Two people can have the exact same income, but totally different levels of financial stress depending on when things happen to them.
Let's dramatize this with the article's example. Let's take two people, Alice and Bob. They both start the month with the exact same budget. They both like to have a nice bottle of wine with dinner on the weekends. Alice is type A. She does all her shopping on the first of the month. She stocks up.
I wish I were Alice. I'm Bob.
And Bob is a procrastinator. He goes shopping on the 28th when he realizes the pantry is empty. Now imagine a supply shock happens on the 15th of the month. A sudden frost in Italy kills all the grapes. The price of that specific wine doubles overnight.
So Alice already bought all her wine for the month at the old price.
Alice paid $20 a bottle. She's happy. She's at home enjoying her wine, completely oblivious to the price spike. Bob, however, walks into the store on the 28th. The same bottle that Alice bought is now $40. Bob is hit with a choice. Either pay double and wreck his budget, or switch to cheap beer and be miserable.
Poor Bob. I feel his pain.
Now, at the end of the month, the government measures the Consumer Price Index, the CPI. They average the price from the start of the month and the end of the month. They might say, overall, wine inflation was 50% this month. Alice hears this and says, what are you talking about? Prices didn't change at all for me. Bob hears it and says, are you crazy? Prices doubled. The national average describes neither of their actual experiences.
And the state function view says they're in the same boat because maybe they both ended the month with the same amount of money left. But the path function view sees that Bob took a much harder, much more expensive path up the mountain that month.
Exactly. Weaver argues that because prices fluctuate constantly and because we all buy different things at different times and in different orders, our personal inflation rates are wildly different from each other and from the national average. The CPI is a static snapshot that completely ignores the path. It ignores the timeline. It ignores Bob's bad luck.
This explains so much.
Yeah.
It explains why I can talk to my neighbor and we have completely different views on the economy. Maybe I had to buy a used car right when the chip shortage hit and prices were insane. He bought his a year earlier. My path was brutal. His was easy. But the news treats us like we're the same person living in the same economy.
Yes. And Weaver brings it back to the geometry. He calls the Divisia Index, that gauge theoretic solution, anti-fragile because it respects the path. It has plasticity. It bends with your choices, with Bob's bad luck. The Laspeyres Index has stiffness. It's rigid. It breaks when you try to bend it around the reality of Bob's life.
Okay, so we have established that the current ruler is broken, that flat earth math is failing us, and that the heat in the economic engine is burning us all differently based on our unique paths through the market. Now we get to the solution. And I have to say, this is the part where Weaver goes full Tony Stark. He proposes building a laser ring gyroscope for value.
I love this analogy. It is so visually specific and, frankly, cool.
It's super cool, but I need you to walk me through it slowly. I know what a gyroscope is. It's like a spinning top that stays balanced, right?
Yeah.
But what is a laser ring gyroscope?
Okay, it's a very clever device used in modern aviation and space travel to navigate without needing GPS or looking out the window at the stars. Imagine you're in a spaceship, deep in the void. There are no stars to guide you, nothing to look at. How does the pilot know if the ship is turning left or right or pitching up or down?
You can't feel it in space. There's no inertia in the same way.
Right, so they use something called the Sagnac effect. Picture a hollow ring or a loop of fiber optic cable inside the ship. You fire a laser beam and you use a special mirror to split it into two identical beams. One beam is sent clockwise around the ring. The other beam is sent counterclockwise.
Okay, so you have two beams of light racing in opposite directions or on a circular track.
Exactly. Now, if the ship is sitting perfectly still, not rotating at all, Those two beams travel the exact same distance. They arrive back at the starting point at the detector at the exact same instant.
A perfect tie game.
A perfect tie. But now imagine the ship starts rotating clockwise. Just a little bit. The beam that is also traveling clockwise is now chasing the detector. The detector is running away from it as the ship turns, so it has to travel a slightly longer distance to catch up.
And the other beam, the counterclockwise one.
The counterclockwise beam is moving against the rotation. The detector is rushing towards it, so it travels a shorter distance.
So one arrives late and one arrives early. They're no longer in sync.
Exactly. And because light is a wave, when these two out-of-sync beams meet at the detector, they create an interference pattern. The peaks and valleys of the light waves don't line up anymore. They clash. They create stripes of light and dark. The computer on board counts those stripes. They're called fringes. And from that pattern, it knows exactly how much and how fast the ship turned. It measures the curvature of its own path through space.
That is wildly cool. Physics is basically magic.
Okay.
So that's a spaceship. How on earth do we build this for the economy? We don't have lasers. We don't have mirrors.
Weaver says, you don't need them. Substitute the physical components with informational ones. Component 1, the light source. Instead of a laser, we use a continuous high-frequency stream of granular transaction data.
So not a guy with a clipboard checking milk prices once a month.
No, not at all. We are talking about the real-time feed, every credit card swipe, every UPC scan at a grocery store, every Venmo payment, the raw, unfiltered pulse of every single purchase happening in the economy millions of times a second.
That data definitely exists. I mean, Visa has it. Amazon has it. The banks have it.
Right. So that massive data stream is our light, component 2, the split beams. We take that data in real time and we run it through two different algorithms simultaneously. Beam A is the looking back algorithm, the Laspeyres math.
The ghost of basket.
And beam B is the looking forward algorithm, the Posh math.
The sci-fi basket. See where this is going. We pit the two old fighters against each other in real time inside a computer.
We send beam A traveling metaphorically into the past and beam B traveling into the future. Now remember the index number problem? The fact that the Laspeyres and Pash indices never, ever agree.
Right, the gap between them. One says 3%, the other says 2.2%.
In Weaver's model, that gap isn't a mistake to be averaged away. That gap is the interference pattern. The difference between the Laspeyres number and the Pash number is caused by the rotation of the economy, by the curvature driven by changes in technology, preference, and substitution.
So you're telling me the thing that economists have been complaining about for 100 years, oh, these two numbers don't match, what a nuisance, that was actually the most valuable data all along.
Yes, that is the aha moment of the entire paper. The discrepancy isn't noise. The discrepancy is the measurement of the curvature. It's the signal. So Weaver says component 4 is the readout. We use the Divisia Integral, that's the fancy math from Malaney and Weinstein, to count the fringes of that interference pattern.
Okay.
It takes the gap between the two indices, that constantly changing spread, and it mathematically resolves it into a single perfect line that tracks the true path-dependent change in value.
So instead of ignoring the discrepancy or just averaging it out, we use the precise shape of that discrepancy to calculate exactly how much our purchasing power has rotated or curved over time.
Precisely. It's an inertial navigation system for wealth. Just like the pilot trusts the gyroscope to tell her exactly where she's in the dark, we could trust the Divisia Index to tell us what our money is actually worth, regardless of the weather or the heat or the political spin.
This sounds solvable. I mean, it sounds difficult, but solvable. The math is proven. The data exists. We live in the era of big data. We are drowning in transaction logs. So why don't we have this? Why am I still looking at a CPI number that comes out once a month and feels completely fake? Why are we still using the rubber tape measure?
And this is the final and perhaps the most cynical part of Weaver's argument. He calls it the technology readiness level gap, which is a polite way of saying the tech is still theoretical. But the real villain here, the real reason it's not implemented, is what he calls political mass.
Political mass, meaning the government is heavy and hard to move, like inertia.
Meaning the government, and more specifically the central banks, have a vested interest in keeping the broken ruler. Think about it from their perspective. As a politician or as a Fed chair, do you really want a speedometer for the economy that is perfectly accurate, down to the decimal point, in real time?
Probably not. If the economy is crashing, I want to be able to say, well, if you look at the 6-month average, it's actually stable. I want some wiggle room.
You want wiggle room. You want plausible deniability. The current CPI is great for politicians because it is slow, It's infrequent. It is an average of averages. It smooths out all the scary spikes. It allows for what Weaver calls narrative control.
If we adopted this path-dependent gauge, this real-time laser ring gyroscope, it would show everything.
It would reveal the true volatility of the currency. It would show the economic storm in all its violent detail. It would expose the entropy in high definition.
And people would panic.
People would demand action. Weaver writes, and I'm paraphrasing here, adopting a gauge that reveals the true path-dependent volatility of purchasing power would break the predictable broken ruler they rely on to set policy. They wouldn't be able to steer the ship if every passenger could see the waves crashing over the bow in real time.
Man, that is dark. It's easier to govern when you control the reeler, when you control the map.
It is. But Weaver doesn't end on that cynical note. He doesn't end on the conspiracy. He ends on a vision, a very powerful one. He calls it the democratization of measurement.
What does that future look like?
Imagine a future where you don't listen to the Federal Reserve Chair to find out if inflation is up or down. Imagine you just log into your bank app, and right there, next to your checking account balance, is a personal inflation dashboard.
Tailored to my path. My specific spending.
Yes. Not the national average, yours. It's connected to your specific spending stream, your credit card data, your mortgage payment, your utility bills. It calculates your personal velocity. Hey, you're spending 10% faster this month. It calculates your personal entropy. And it tells you, in plain English, based on the specific items you buy, the brand of wine you like, the gas station you use, the cost of your kid's tuition, your personal inflation rate is 12%.
Even if the news that night says the national average is only 3%.
Exactly. It validates your reality. It proves you're not crazy. Weaver calls this ending the era of phantom inflation.
Phantom inflation. That's that gaslighting feeling again. The feeling that you're losing, but the scoreboard says you're winning.
Yes. Phantom inflation is being told you are fine when you feel like you are drowning. But if you have that dashboard, the phantom disappears. It's replaced by hard data. You can walk into your boss's office and say, no, I'm not crazy. My personal purchasing power dropped 12% last year. I need a 12% raise just to break even.
It gives you agency. It turns you from a passenger, or maybe a victim of the economy, into, well, a pilot. A pilot with a working gyroscope in their own cockpit.
It empowers you to make what he calls anti-fragile choices. You can navigate the storm because you finally trust your instruments. You're not flying blind anymore.
That is such a powerful image. And it makes me think about that political mass thing again. Weaver says the government won't build this for us, but couldn't someone else? Couldn't a startup build this? Couldn't a bank offer this as a premium feature? Switch to our bank, we tell you the truth about your money.
I think that's inevitable. I mean, the data is already there. The math is public knowledge. Eventually, the demand for truth will outweigh the political convenience of the lie. The political mass will be forced to shift because the people will have better maps than the government does.
That would be a revolution. Not a loud one, but a quiet, data-driven one. Imagine an election year where 150 million people can look at their phones and see their exact personal path-dependent inflation rate graphed out over the last 4 years.
No more spin. No more. The economy is the strongest it's ever been.
Just 150 million individual data points of truth. How would that change how we vote? How would that change what we demand from our leaders?
It would enforce a level of accountability we have never seen in economic history. You can't hide from the data when everyone has their own personal gyroscope. The noise becomes the signal.
It's a lot to think about. We've traveled from a crooked house with a shrinking rubber tape measure through the flat earth mistake of using 19th century math on a 21st century curve. We've seen how money is energy, and inflation is the waste heat that burns us all differently. And now we've seen the blueprint for a machine that could finally tell us the truth.
It's a dense topic for sure, but the takeaway is surprisingly simple. The ruler is broken, but it doesn't have to be. We have the tools to fix it.
So next time you're at the store, deciding between the steak and the chicken, and you feel that pang of phantom inflation, just remember, it's not in your head, it's in the geometry. This has been The Deep Dive. Thanks for listening.
Stay curious.